Hello, my name is Jason Buss, and you are here at News at 10:52, and welcome to our show. Now today is February 22nd, 2008. We have actually backed up 11 years from our current time period to talk about a special man, famous scientist, Joshua Lederberg. He has passed away on this date specifically. Now for our show, we're going to do a special segment to honor him, talk about his famous accomplishments, and his early life. Thank you. Joshua Lederberg, a man of many talents, microbiologist and famous Nobel Prize winner in 1958. He was born May 23rd, 1925 in the city of Montclair, New Jersey, to a Jewish family and the son of a rabbi to the local church. He was one of 3 children with 2 brothers. There he moved up to Upper Manhattan, New York City, where he graduated from high school at the age of 15. At the age of 15, he actually attended Columbia University, where he'd meet a mentor, F.J. Ryan, from 1941 to 1944. From zoology, he moved to microbiology in 1946 at the College of Physicians, where he met his future Nobel Prize winner, sharer, Edward Tatum. There, they discovered previously that bacteria would be cloning itself. However, that is wrong, and they actually discovered that bacteria does a little thing called bacteria conjugation, which we will get into now. Now, while Joshua Lederberg was at Columbia, he actually had a hypothesis for bacteria. Previously, it was believed before that bacteria would actually take its genetic DNA, or its genes, and copy itself, essentially making a clone. Now his hypothesis wasn't getting him anywhere, so he decided to contact Edward Tatum and tell him about it. Later he met up with him, a couple years later, at the College of Physicians. There, they discovered a little thing called bacteria conjugation. Now, 2 things you need to know is a donor and a recipient. This donor contains an F plasmid and an F pilus. This F plasmid is essentially the DNA genes that it's going to share with the recipient, which is another bacteria that does not contain an F plasmid. The F plasmid is able to attach an appendix part, so it is able to create a bridge between the donor and the recipient. The F plasmid contains 2 strands, which, once they make contact, form the bridge. They need an endonuclease, which is an enzyme, to create an origin of transfer on the 2 strands. Now, the outside strand is slowly unattaching itself, and while it's slowly unattaching itself, the F plasmid is actually synthesizing or recreating that strand that is about to be lost. The strand exits from the donor, moves over across the bridge into the recipient, and that recipient is able to clone or synthesize another part of itself to fully recreate the F plasmid. Now, that bridge is cut off, and they both move on as separate donors, which they are able to move on to their recipients and share their DNA amongst each other. Joshua Lederberg and Edward Tatum would later win the Nobel Prize in 1958 for the discovery of bacteria conjugation. Bacteria conjugation actually is helping us today discover why antibiotic resistance exists, because bacteria is able to share its genes, therefore become more resistant to antibiotics. Thank you, Joshua Lederberg. May you rest in peace, and may you all wish a good morning and good night, because it's 12 o'clock.